Picture this, January 19th, 2038. Your alarm doesn't go off, power systems start glitching, even your favorite game won't load. Sounds like a sci-fi disaster movie, right? Well, it's closer than you think. Have you ever wondered how computers keep track of time? It's something we often take for granted, but it's actually quite fascinating. Today, we're diving into a topic that might sound like it's straight out of a science fiction movie, the year 2038 problem. Stick around as we unravel why all the computers in the world could potentially face catastrophe on January 19th, 2038. Every computer system needs to keep track of time for various reasons, whether it's for logging events, scheduling tasks, or simply displaying the current date and time. And to do this, computers use a system called Unix time. Unix time works by counting the number of seconds that have elapsed since a specific starting point, January 1st, 1970. It's like a giant stopwatch that's been running in the background of every computer system for decades. But here's where things get interesting. Unix time represents these seconds as a 32-bit signed integer. Now, what does that mean? Well, imagine you have a jar that can only hold numbers from -2,147,483,648 to 2,147,483,647. Once you reach that maximum value, it's like the jar overflows, and you have to start counting again from the negative side. This overflow is precisely what's going to happen on January 19th, 2038, in the world of computer timekeeping. We call it the year 2038 problem, and it's similar to the infamous Y2K bug that had everyone worried as we approached the year 2000. But instead of a two-digit year causing chaos, it's the limitation of a 32-bit integer representing time that's causing a stir this time around. As we march forward in time, the seconds keep ticking away, and eventually, we'll reach a point where that 32-bit integer will hit its maximum value and overflow. Picture it like a digital odometer rolling over to all zeros, but in this case, it's like the odometer flips back to negative numbers. And that's not good news for our computer systems, which rely on accurate timekeeping for countless essential tasks. So why is this such a big deal? Well, imagine your bank transactions suddenly going haywire, your GPS navigation leading you astray, or your communication networks failing to deliver messages on time, all because the computers behind these systems can't keep track of time accurately anymore. Let's talk about what it could mean for our everyday lives. The implications are vast and varied, touching virtually every aspect of modern society that relies on computers. Think about financial institutions, for instance. Banks and investment firms use computer systems to process transactions, calculate interest rates, and manage accounts. If these systems start spitting out incorrect timestamps or get stuck in a time loop, it could wreak havoc on our financial stability. And what about transportation? From airplanes to trains to autonomous vehicles, so much of our modern transportation infrastructure is dependent on precise timing. If computer systems controlling these vehicles start malfunctioning due to the year 2038 problem, the consequences could be disastrous. Communication networks are another critical area that could be severely affected, whether it's sending an email, making a phone call, or streaming your favorite movie. These activities rely on accurate timekeeping to ensure smooth operation. Any disruption in timing could lead to delays, dropped connections, and a general breakdown in communication. The good news is that we're not sitting idly by waiting for disaster to strike. There are proactive measures being taken to mitigate the effects of the year 2038 problem and ensure that our computer systems remain functional well into the future. One of the most straightforward solutions is to transition from the 32-bit time representation to a 64-bit representation. By doubling the size of the integer used to store time values, we can extend the range of representable dates far beyond the year 2038. Many software developers and system administrators are already hard at work updating their systems to accommodate this change. They're rewriting code, updating libraries, and performing extensive testing to ensure that their applications will continue to function seamlessly after the transition. In addition to transitioning to 64-bit time representation, there are alternative timekeeping methods being explored. These include using alternative calendars, such as the International Fixed Calendar, or adopting time formats that aren't tied to a specific starting point, like International Atomic Time or GPS time. By working together, staying informed, and taking proactive measures, we can ensure that the year 2038 problem doesn't become the catastrophe it's poised to be. Thank you for watching.